Welcome everyone. We will be talking about business statistics in today's video. Simple and straightforward. This I have tried to keep the statistic concepts on a very basic level. Now, why do we go for statistics? Now, statistics helps us to arrive to a decision. Now, talking of decisions, decisions are taken under certain conditions, right? Conditions like we are having a full knowledge of the things, that is certainty, and certain conditions like we do not have the requisite knowledge thereby in terms of uncertainty. So dealing with uncertainty, everyday decisions, remember, is always based on incomplete information. So let's say, will the job market be strong when I graduate? One of the questions that might be springing in your mind. Will the price of Yahoo stock be higher in 6 months time, probably from now? Will the interest rate remain as low for the next rest of the years if the federal budget deficit is as going to be as high as predicted? No, these are certain things, these are certain questions that might be springing in anybody's mind, and probably everybody's might be giving answers to their equipment as far as thing. So numbers and data are used to assess decision making, and this uncertainty, if we can need to iron out this uncertainty altogether, we are utilizing numbers, we are utilizing data. Statistics is the tool to process, probably summarize, analyze, and interpret data thereby. So what are the things we are looking into it? We are trying to process, summarize, analyze, and interpret data. Whenever we do this, the process is known as statistics. Key definition: a population, we're talking about a population is a collection of items of interest or under investigation. Now, everything might be a population. Let's say N represents a population size. N as in the capital N, if I may say so. This is what we are talking around it. A sample, on the other hand, is observed as a subset of the population, a part of a population. And again, an N represent, but this time a small n. Unlike the population, which has been represented by caps, in caps, the alphabet n, in sample would be again without caps, the smaller n. A parameter is the specific characteristics of a population that the population depict, exhibits, or is very much renowned for. A statistics is the specific characteristics of a sample per se, as the case might be. Yes, I have given you a pictographical representation of sample, and if you look into it, the population, which is very simple, straightforward, given to you in the graph, is where I have put in all the 26, 27 alphabets letters, that is A, B, C, D, E, F, G, H, I, J, K, L. So value calculated using the population data, which is known as parameter. Now, this is a parameter. Now, if you have to take a sample of it, I might take certain things. For example, alphabet B, C, G, I, N, O, R, U, Y. Perfectly random things. So these are the value computed from the sample data, is what statistics is all about it. Why do we take a sample? Because it might become very cumbersome, tiresome to analyze each and every data of a population. Why? Because the population might be a very big data that we're talking about it. But and then what is the use of sample, that you, if you may so? Because sample is a smaller data which exhibits a similar characteristic that the population is going to display or demonstrate. So examples of population, let's say names of all registered voters in your country, perhaps United States. Let's say incomes of all families living in a particular area, let's say Dayton Beach. The annual returns of any stock traded in a New York Stock Exchange, NYSE, as in the case. Grade point average of all students as per your university. Now remember, this population is so big, it's quite big. In fact, it's enormous. The real word right now being termed as big data per se, and that is what we are looking into it. Now let us come on to random sampling. Now random sampling is a simple procedure of having an each member of population chosen strictly by chance, absolutely by chance. There is no probability of any sample being getting picked up than the other one. So each member of the population is equally likely to be chosen. Every possible sample of n objects, remember n is the smaller n, the sample size, is equally likely to be chosen thereby. So every object has an equal chances of being picked up or being studied. The resulting sample is known as random sampling. Now let us talk about the descriptive and inferential statistic. Two branches. Remember, these are two branches of statistics that I'm very fond of. Descriptive statistics and inferential statistics. Descriptive statistics are graphical and numerical procedures to summarize and probably process data. Inferential, on the other hand, using data to make prediction, forecast, estimate, and assist decision making, arriving at a decision. Now that is what inferential statistics is all about. It. These are the data which needs to be extrapolated, or it gives you a kind of sense making, perhaps to give you a direction altogether, and that is what helps you in coming or arriving to a decision. Descriptive statistics, let's say we collect a data. Let's say example would be a survey. We can always take a survey for anything and everything, present those data in terms of some kind of chart, some kind of table, and then summarize it as in the simple mean, the arithmetic mean, the geometric mean, the median, the preferences, the majority chances. The simple mean is the summation divided by the number of population that, or the number of sample size divided it altogether. Ooh, look what we have done with the population as have been shown in this particular video. If you can see, there are a number of people irrespective of the genders. I have marked few of them with the color red. The whole population is everybody included, but only the color red people have been marked as a sample. So estimating the population mean weight using a sample mean weight. Absolutely, the weight of the population per person on an average. Hypothesis testing can be test the claim that the population mean weight is approximately 140 pounds. So inference is the process of drawing conclusions, making a decision about a population based on a sample result. Now, types of data. Now, data are again of two types. One is categorical and numerical. Now, let us approach the categorical data. The categorical data can be anything and everything. You know, it can be a marital status. You are registered for a vote, but might tell you your age. What is the color of your eye? Is your color of your eye blue? Is it brown? It is hazel. Defined categories. Now, these are categorical data that I'm talking about it. Let us talk about the numerical data, the discrete data and the continuous data. Numbers of children, defects per thing. The discrete data will be talking about the number of children, defects per hour, counted hours. Continuous data would be about your weight, about your voltages thereby, and so on. Measurement levels. Now we're talking about various levels that comes around in terms of qualitative data and quantitative data. Now remember the difference between measurements, that is true and zero exists. That's the ratio data we're talking about it. The difference of measurement between no true zeros are the interval data. Absolutely, the interval data we are talking about. Now, ordered categories are ranking orders, as in the ordinal data is concerned, and categories with no ordering, no direction, no sense. It's the nominal data. So, yes, ordinal data and nominal data are qualitative data, whereas the ratio data and interval data are quantitative data thereby. So, geographical representations or of data, if I may say so, data in a raw forms are usually not easy to understand, easy to dissect, and probably arrive into a decision making. Some type of organization or sequencing is required, let's say in the form of a table or on a graph. The type of graph to be used depends on the variable to be summarized thereby. Now, geographical presentation, the techniques might be categorical view. Let's see the frequency distribution, bar chart, pie chart, Pareto diagram, as on when on basis. Now, these are the categories variable that comes around it. The frequency distribution, the bar chart, the pie chart, the Pareto diagram. Numerical variables would be all of line chart, frequency distribution, histogram, ogive, stem and leaf, or the fishbone methods, or the scatter plot, as in the case. Talking about categorical data, we are talking about tabulating and graphing data. In tabulating data, the frequency distribution tables are being mentioned. In graphing data, it is all about pie chart, it is all about bar chart, it is all about Pareto's diagram, as on when on basis. The frequency distribution chart, I'm just giving you an example for you to understand. Each one of you should be able to accumulate and write it down very slowly and understand everything with point. So this is what been given in a hospital. How many patients are looking into the cardiac care? How many are in the emergency? How many are intensive care unit? How many are in the maternity ward? And how many are in the surgery? It gives an hospital data via categories, right? This is frequency distribution. We can have the pie and the bar chart. The bar chart and the pie chart are often used as quantitative or qualitative data. Height of the bar or the size of the pie slide shows the frequency or the percentage of each category thereby. Yes, this is a slide which can reflect into a data. Similarly, I have just utilized the hospital data that was presented out there and been reflected in a graphical format. Here it seems in a bar chart. Here you can see what has been mentioned in the bar chart. Now, if I want to move it into from a bar chart to a pie chart, probably for a different visualization effect, this is how it will be reflecting around it. Please watch into it. Here again, it's been categorized as in surgery, cardiac, emergency, intensive care, and maternity ward, as the case might be. Let us come into the next topic for you to understand. Pareto diagram. Now used to portray categorical data, a bar chart when categories are shown in a descending orders of frequency. A cumulative polygon is often shown in the same graph, used to separate vital few and a trivial many thereby. Now, this is what is very true. The vital few and the trivial many, which we'll be talking about Pareto's chart. It's an 80-20 ratio that we keep on coming around with Pareto. Vital few and trivial many is what we are looking. So look at, let's say, an example of 400 defective items were examined for the cause of the defect. 400 defective items were examined just to find out the cause of the defect. Now, if you can say it can be bad welding, might be 34 defects, poor alignment, 223 defects, missing part, 25 defects, paint flaw, probably 78 defects, electrical short, 19 defects, cracked cases, 21, and in totality, all of the defect comes across as a 400 defective items. Now, can we do it with Pareto's diagram? Probably yes, definitely yes. Why not? And sort the defect in order of descending order and determine the percentage. You will see the poor alignment versus 223 defect was approximately 55.75 percentage, and the next was the paint flaw, which was 78 degree. That means approximately 19.5 degree, 0.5 percentage, and so on and so forth. You look into it. If these two defects can be aligned, you have removed 80% of the defect altogether by yourself, approximately 80% or 75% per se. Now, this is the Pareto's diagram, which shows what to be done, the percentage of defects. Now, and the cumulative of the line graph that comes around it. This gives you a total picture on what to work upon, what decisions are required, where the thrust of the manager should be going around it. Now, let me take you to the next graph, which is known as a CAP, graph for time series data. A line chart, time series plot, is used to show the values of variable over a period of time. Time is measured on a horizontal axis. The variable of interest is measured on a vertical axis. Remember, time on an x-axis and the variable of interest is always on the y-axis. Look at the just a glorifying example of a magazine subscription by the year, and you see the zigzag fashion that comes around it. Remember, time should always be on the x-axis, and the point of interest, the variable of interest, on the y-axis. And if you plot it, this is a line diagram that comes around. Now, let us look into to describe numerical variables. How do we go around it? We can go for frequency distribution or a cumulative distribution. Frequency distribution would be Ogive and historical chart, whereas a stem and lift display would be just a stem and lift. I will show it to you in the subsequent minutes. Frequency distribution, what is it? Let us talk about it. It's a list of or a table, simple and straightforward. It's just a list or a table containing classes or grouping, categories or ranges within which the data fall. The frequency, if I'm talking about it, the corresponding frequency for which the data will be talking around. So in the age group of 0 to 6, 7 to 12, 13 to 19, you can have the age group and what is the sample population or the population of each group participant out there. Now that is what your class grouping is all about: 0 to 6, 7 to 12, and perhaps 13 to 19, and so on and so forth. Class grouping. Frequency would be number of people figuring out on those groups. So why use frequency distribution? A frequency distribution is a way to summarize data. The distribution condenses the raw data into a more useful form and allows for a quick visual interpretation of the data thereby. Let us come up with the class intervals and the class boundaries. Each class group has the same width. Determine the determine the width of each interval. Let's say the width is all about the largest number to be deducted from the smallest number and divided by the total number of desired intervals. Use 5 but not more than 15 to 20 intervals. Intervals should never overlap. Did I say 0 to 6, 7 to 12, 13 to 19, and so on and so forth? There was no overlap out there, right? Though this was not depicted on the on your video, but probably I'm giving you a pertinent example for you to understand time and again. See, a manufacturer for insulation randomly selects 20 wintry days and records the highest temperature. Let me give you a practical example. 20 of the coldest days and the highest temperature has been recorded, and you can see the recording of the data. Remember, this temperature is not in Celsius but in Fahrenheit. Sort those raw data in ascending order, and now we are going into the Pareto methods. In Pareto method, we were following the descending things. Out here, it is in ascending order, and then particularly start finding the range. Now, how do you find the range? The highest data, and to be subtracted by the lowest one. And out here, if you look into it, 58 degree Fahrenheit and a 12 degree Fahrenheit being the highest one. So difference is 46. Now, if we can select a class of 5, let's say usually it usually ranges from 5 to 15. Compute the interval. Let's say 46 divided by 5 and round it up altogether, and you will have somewhere around 9 degrees or 10 intervals. Count the observation and assign to the class thereby. And this is how it will be looking into interval of 10 but less than 20, interval of 20 but less than 30, interval up to 30 but less than 40. That is what we are looking into it. The frequency being 3, 6, 5, 11, the relative frequency, what it comes around it. The percentage is cumulative, is all about it. And that is what has been meant. Histogram, the graph of data in the frequency distribution is called histogram. The interval endpoint are shown as horizontal axis. The vertical axis is either the frequency, relative frequency, or the percentage. Bars to the appropriate height are used to represent the number of observation within each class per se. And that is what histogram would always be reflecting around it. Here is the glorifying example of histogram. The pictographical representation. You have those intervals, and then you have everything that has been reflected out there. Now, histogram daily temperature that comes around it, and if you look at this has been mentioned out there, there are no gaps between the bar, absolutely no gaps between the bar. So questions about grouping the data are probably into an interval. How wide should be the interval? How many classes can be utilized? What should be the endpoints of interval be determined? Often answered by trial and error method. Obviously, yes, subject to the user judgment. The person who is depicting the data, reflecting upon it, and putting a graphical connotations to it. The goal is to create distribution that is neither too jagged or too blocky. Goal is to appropriately show the pattern of variation in the data per se. So how many class variables? Now, if you look into it, too many would be narrow class variables, too wide will be very few class variables. So narrow class variables intervals may yield a very jagged distribution per se. Can give you a poor indication of how frequency varied across classes. Wide class intervals may comprise variations too much and yield a blocky distribution. Can be obscured and important patterns of variation. Probably you will not be able to diverge or dissect the data, come to a situation of understanding. So yes, the cumulative frequency distribution, again with the same data of having the highest temperature recorded on the wintry days, right from 12 degree Fahrenheit to 58 degree Fahrenheit. You have those frequency band of 10 but less than 20, 20 but less than 30, and the frequency percentage. Now, if you look into the frequency percentage, you can accumulate 3 plus 6. Please understand, this is the 3. 3 plus 6 becomes 9. Now, 9 plus 5 will become your 14. And this is what exactly has been done accordingly. And the percentage would also be cumulative. This is 15 percentage. Yes, 15. 15 plus 30. 30 becomes 45. 45 plus 25 should become 70. And that is how it goes around. The data are in an ordered array. The Archive is how it comes around it. You can come with an Archive chart with the help of a daily high temperature, which can be less than 10, in between 10 and less than 20, in between 20 and 30, in between 30 and 40, and so on and so forth. The Archive chart comes into display, comes alive, right? It is quite differ from the histogram thereby. Let us move to the stem and leaf diagram. A simple way to distribution details in a data chart method: separate the sorted data series in a leading digit, the stem, and the trailing digit. So one is the leading indicator, and the other one will be a trailing indicator. The leading digits is the stem, and the trailing indicator, dependent thing, would be your leaves. So data in an array tray, if you look into it, is simple. Here is the 10 digit of a stem unit that goes around. 21 can be shown as stem being 2, leaf being 1. 38 can be shown as stem being 3 and leaf being 8, as the case might be. So data indicators which how many 2s are there and how many 3s are there and how many 4s are there. It is 21, 24, 24, 26, 27, 27, 27. So we can have 2 as a stem indicator, leaves between 1, 4, 4, 6, 6, 7, 7. Similarly for 30, 32, 38, there are only 3 stem and 0, 2, 8 as a leaf indicators, as the case might be. Now remember, we are building this diagram from this data. So this is very important. The data needs to be decided upon, and probably from there we need to break it out. So using 100 digits as a stem, round up the 10 digits to form the leaves per se. So similarly, 613 would become 6 being the stem, leaf being the one. 776 would become 7 being the stem, 8 being the leaf, and so on and so forth. So use a complete 100 digits of the stem. The completed stem and leaf display will look like this if you look out here. Absolutely. The data is 613, 632, 658 and 717. What does it mean? For the stem, it becomes 6, 1, 3 and 6. See, plain and simple that comes around. Now, we are looking at the data stem for 720, 750, 776, 717. Now, how do we go for the stem data and the leaves data thereby? Relationship between variables graphs illustrated so far have actually involved only one single variable. When we are having two variables existing, what are the techniques to be utilized? Now we can utilize something called categorical variables in the form of cross table, and numerical variables in terms of a scattered plot. Allow me to discuss those cross tables and scattered plot for your understanding. Scattered diagrams are used for paired observation taken for two numerical variables. The scattered diagram, one variable is measured on the vertical axis and the other variable always on the horizontal axis. Remember, the scattered diagram, one variable is measured on a vertical, the other one is on the horizontal axis. We are talking about scattered diagram with a paired observation as and when on basis. So let's say I give you an example, the volume per day and the cost per day. It might be our sales. What are we looking into? The production volume that we are looking into it. So cost per day on the vertical axis or the y-axis, and volume per day, the production volume we are talking about on the x-axis. And if we can plot this data, what is the data? This is the data that I'm talking about it. If we plot this data, there is this graph, and this graph is known as a scattered graph. It will actually be plotted on the graph with accurate depiction. Cross tables, on the other hand, are contingency table. List the number of observation for every combination of values for two categories or ordinal variables. If there are R categories for the first variable, let's say rows, and if there are C categories for the second variable, let's say columns, the table is known as R into C or R cross C, and that is a cross table that we are talking about. Again, repeating it for your understanding, contingency table lists variables, two variables of observation. It is always in a categorical or an ordinary variable depicted on either on the rows or on the columns, X or Y axis, which can be crossed into it. So what are we looking out here? Here is it what can be said. Now this is a cross table that has been mentioned out here. If you look into it, there are three investors, investor A, B and C, and they have invested categories into stock, bonds, company deposits and savings per se. So simple and straight, stock, bond, company deposits and savings. So investors A has been marked how much in the stock, how much in the bond, how much in the company deposit and savings. Similarly for investor B, similarly for investor C, and we have arrived to a situation of the total amount that comes around it. Now this is where it can be depicted on a graph. This is a side-by-side chart that has been mentioned. Here with the company, the investors, we are moving into saving, we are moving into the company deposit, the bond, the stock. For the investor A's, B and C have been classed in different colors altogether, and that is what we are looking forward to. Now let me come across similar chart in a side-by-side chart example, wherein the sales of three territories, let's say east, west, and north, first quarter, second quarter, third quarter, fourth quarter, is been depicted, and we can show it to you. And wherein, like the earlier investors A, B, and C who are investing their things in stocks, bonds, charts, and so on and so forth. Probably this can be another method of showing it to you. So now let us come to the data errors, presentation error, we are looking into it. Goal for effective data presentation, presentation data to display essential information. Present data, absolutely to display the essential information, nothing else. Communicate complex idea very clearly and accurately. Data, probably it will still confusing, but graph, absolutely clearly, this still clear. Everybody will be able to understand. Avoid distortion that might convey the wrong messages thereby as on when on basis. The data presentation error, unequal histogram, interval width, one of the major thing avoided. Compressing or distorting the vertical axis, again avoid it. Never do that thing. In fact, if it goes elongates, get it done with it. Providing no 0 point on a vertical axis, absolutely a must know. And failing to provide a relative basis for comparing the data between the groups, that is a must thing that goes around it. With this, I come to an end of this particular presentation. I'm sure everybody is very clear with data visualizations and how does it comes around it. The business statistics we will be talking around in this presentation. We'll talk about data visualization in the subsequent presentation. Thank you for watching this video till the very end.